So welcome everybody, thanks for coming. This is an experimental talk. My slightly random starting point for my talk today is something Eric Evans said in the keynote he gave at this conference last year in which he discussed modelling time. He asked a very interesting question, what if we didn't have instants? I'm going to talk about events, warming up with some hopefully obvious stuff, working towards the concept of the event as an occasion of experience as proposed by Alfred North Whitehead. I will end up with some examples. Firstly, let's see what the dictionary says about events. An event is something that happens. You can use events to describe all the things that are happening in a particular situation. Let's get started by thinking about events in software. Perhaps it's a file on a computer, but even if it's printed on paper, it's a fact of at least one episode of software. It's a fact of at least one occasion of software development, the process by which it was created. Hopefully, it's also something that actually runs on a computer. When a program runs, there are lots of events. A high-level program will be parsed somehow. Something is compiled, bytecode or machine code. Machine code runs, transistors switch, electrons move. There are events within events, and events followed by events. Now let's say we run a software application that has a domain model in a layered architecture. Perhaps it's even a domain-driven design. Let's say the model has aggregates and value objects. Let's say we have entities representing different things we find in the domain. And let's say the model changes are not coded explicitly as domain events. If we don't code explicitly for domain events, for what happened, then we can't expect afterwards directly to determine exactly what changed in the model. That means any notification messages about the change must be published when the database is updated. In this case, sending the notification message is separate from updating the database. So a message could be sent about something that wasn't recorded in the database, or something could be recorded in the database without a message being sent. In consequence, infrastructure failures can affect the state of a distributed system which propagates state in this way. On the persistence level, the records are effectively damaged, but on the level of the domain, what is broken is the subsequent perception of what happened. What happened previously on the level of the domain. The perception is that something else happened. We can't eliminate infrastructure failure, but we can eliminate misperception so long as we can identify what's actually happening in the processing. Just before we do that, let's think about objects. Here's Martin Fowler in 2002 in his book Patterns of Enterprise Application Architecture, which I really loved. To build a good domain model, you should have an understanding of conceptual thinking about objects. So what does that actually mean? What does it mean to have an understanding of conceptual thinking about objects? I used to feel that I knew what he meant. He continues, Eric Evans is currently writing a book. So let's see what Eric Evans said about objects in 2003. Here's Eric Evans discussing his use of pattern language in his great book, Domain-Driven Design. I also really love this book. When it comes to understanding objects, he said, we need to distinguish bolts from springs. And bolts and springs, are those the actual entities? I used to think so. So what is an object? Here are three definitions. The first one, object in classical analysis, the actual entities are material instances of subject quality categories, which is an inadequate idea from the Greeks. It's an inadequate idea for various reasons. The second definition is a great idea. Objects in software, which, when I first saw it, I just thought it was essentially the collocation of state and behavior in a computer program, an improvement on having data structures with function pointers. What some of us have been doing for many years is to represent the first one with the second one, to represent objects of classical analysis with software objects. On the other hand, when we want to code for domain events, we use software objects to model events. An increasing number of people seem to be doing that. What's the real difference? The trouble with objects seems to be, as Alfred North Whitehead, what Alfred North Whitehead called the fallacy of misplaced concreteness. The current accounts of perception are the stronghold of modern metaphysical difficulties. They have their origin in the same misunderstanding which led to the incubus of the substance quality categories. The Greeks looked at a stone and perceived that it was grey, and he published that in 1929. But of course now, after so many event sourcing presentations, I included this picture. Whereas the Greeks looked at stone and perceived that it was grey, we look at stone and perceive event sourcing. So to give a quick introduction to those who haven't heard about it before, event sourcing is an architectural pattern in which the state of the application is determined by a sequence of events. It's a persistence mechanism for domain-driven design. We can use domain objects to represent what happened in the domain and store those events in the database. It supports reliable propagation of application state because if the events are in a sequence, then others can follow that sequence. But the big question I had was how applicable event sourcing really was. If it is not universally applicable, why would that be? When would it lead straight to disaster, and why? I had no reason to think there was really anything general about events, but I also had no reason to be cautious, except for that blog post which said using event sourcing for everything is an anti-pattern. If thinking about events really did support a general approach, it seemed to touch on my sense of reality in a way that made me feel slightly unsettled, but I wanted to know what the answer was. So as Eric Evans said at the end of his talk last year, research the established formalisms. And so I looked again into process philosophy. The basic idea of process philosophy seems to be that the future doesn't exist and also the past is dead. Process philosophy has a long tradition. In Western thought, process philosophy is traced back to Heraclitus, who's about 500 BC, pre-Socratic Greek philosopher who's famous for his insistence on ever-present change as being the fundamental essence of the universe, as stated in the famous saying, "No one ever steps in the same river twice." This is commonly considered to be one of the first digressions into the philosophical concept of becoming. The phrase "nothing in this world is constant except change and becoming" is attributed to Heraclitus. Process philosophy is now primarily associated with Alfred North Whitehead. In the 1920s, Whitehead wrote, the ancient doctrine that no one crosses the same river twice is extended. No thinker thinks twice, and to put the matter more generally, no subject experiences twice. He follows on by saying, this is what Locke ought to have meant by his doctrine of time as a perpetual perishing. For Heraclitus, everything flows, but for modern philosophy, such absolute becoming is the happening of events. It happens that the biblical phrase, come to pass, works well since events don't change, they just become and then perish. So in 1929, age 68, Alfred North Whitehead published a book called Process and Reality. As far as I can tell, there were 8 contemporary book reviews of the 1929 edition. Axton Clark in the New York Times Book Review, January 5th, 1930, wrote, "Perhaps the situation can best be made clear by saying bluntly that this work surpasses Aristotle's metaphysics and Kant's critique of pure reason for intrinsic importance, though naturally not as yet for historical standing or influence." Wieman wrote in his 1930 review, "Not many people will read Whitehead's recent book in this generation, not many will read it in any generation, but its influence will radiate through concentric circles of popularization until the common man will think and work in the light of it, not knowing whence the light came. After a few decades of discussion and analysis, one will be able to understand it more readily than can be done now." Whitehead was born in 1861, he died in 1947. It was said he was a genial sort of person. He was professor of mathematics at Cambridge and later professor of philosophy at Harvard. Principia Mathematica is Whitehead's most famous mathematical work, co-written with former student Bertrand Russell. Principia Mathematica is considered one of the 20th century's most important works in mathematics and placed 23rd in a list of the top 100 English language non-fiction books of the 20th century. So he is already quite famous because of that. In his later life, he moved to Harvard and started on his philosophical work, of which Process and Reality is his masterpiece. Amongst others, Alan Turing read Whitehead's Science and the Modern World when Turing was at school. There's some library records that show what he checked out of the library, and that's how we know it. Allegedly, we have the word creativity in the English language because of this book. We also get the notion of expression, e.g. in DNA biology from Whitehead, from his writing about the idea of reality creating reality rather than nature somehow being created by a supernatural being in a process of creation. Process and Reality appears as a thoroughly competent reworking of the major depositions in the history of philosophy to isolate things that work and to compose those fragments into a coherent scheme of ideas. In Process and Reality, amongst other things, Whitehead rejects the Cartesian idea that reality is fundamentally constructed of bits of matter that exist totally independently of one another in favour of an event-based or process ontology in which events are primary and are fundamentally interrelated and dependent on one another. Actual entities, also termed actual occasions, are the final real things of which the world is made up. There is no going behind actual entities to find anything more real. They differ amongst themselves. God is an actual entity, and so is the most trivial puff of existence in far-off empty space. But though there are gradations of importance and diversities of function, yet in the principles which actuality exemplifies, all are on the same level. The final facts are, all alike, actual entities, and these actual entities are drops of experience, complex and interdependent. So this is what happens when you don't have instants. If time is not a line that we're sliding along, with the moment being a point on that line, infinitely divided into an infinity of infinitesimal present moment points in time, Whitehead wrote, "The perfect moment is fadeless in the lapse of time. Time lost its character of perpetual perishing. It becomes the moving image of eternity." We can picture eternity as a ball surrounded by the void of the time to come, with the past as layers underneath, and the present distributed around a surface made of evanescent events, effervescing into the future, making it happen. So let's remember this fire and look at what some of Christopher Alexander had to say to see how Alexander's work was illuminated by Whitehead's work, so that we can see how Whitehead has illuminated our work. I was beginning to wonder what the connection was between pattern language and events, but it turns out that Whitehead had an enormous influence on Christopher Alexander. Whitehead actually says quite a lot both about patterns and about language in his book. Pattern language is popularised by the book A Pattern Language for Towns and Cities, which was published in 1977. In 1987, Kent Beck and Ward Cunningham began experimenting with the idea of applying patterns to programming. Ward Cunningham wrote in a paper he co-authored with Michael Mahaffey that wikis were in fact developed as tools to facilitate efficient sharing and modifying of patterns. Martin Fowler suggested patterns create a vocabulary around design. Eric Evans described pattern language as a form for sharing and standardizing design insight. In 1979, Alexander published a book called The Timeless Way of Building, which functions as a general theory and guide for pattern language in general, guiding the reader towards what he called the quality without a name. Alexander writes in his introduction, "When a building has this fire, then it becomes part of nature. Like ocean waves or blades of grass, its parts are governed by the endless play of repetition and variety created in the presence of the fact that all things pass. This is the quality itself." Like Whitehead, Alexander describes becoming coherent within things that pass. That is the quality that makes those things alive. The process of unfolding goes step by step, one pattern at a time. Indeed, this subtle and complex freedom from inner contradictions is just the very quality which makes things alive. At this final stage, the patterns are no longer important. The patterns have taught you to be receptive to what is real. And by real, he means things that pass, in other words, events. So you can see that it's kind of following on really from what Whitehead was saying. There is the becoming a part of nature and also becoming receptive to what is real. The same two events of physicality and mentality have led others to create a split theory of reality. For example, Descartes' mind-body duality. One theory of reality for mind and another for body. Whitehead avoids that by making each event have both to some degree. He calls them the physical and mental poles, but the main point here is that Alexander is obviously trying to say that the actual entities are occasions of experience. A pattern language is a collection of individual pattern descriptions. Each pattern description follows a standard form called the Alexandrian form after Christopher Alexander. Each pattern has a name, a good name which functions as an abbreviated description of the pattern. Next comes the context to which the pattern may apply. Next, after a therefore statement, comes the steps to apply the pattern, which resolves the context, resulting in a greater coherence or harmony, freedom from inner contradictions. Then we have more details about the implementation with examples and possibly also links to related patterns in the language. I've marked the different parts of the Alexandrian form with the 4 different stages and events suggested by Whitehead: datum, process, satisfaction, and decision. What I'm saying is that patterns describe events, and when considering the appropriate form of description for your next pattern language, it seems to me that you can safely stray away from the Alexandrian form if you want to, so long as you don't stray from Whitehead's form and make sure to address the 4 stages: datum, process, satisfaction, and decision, which is what Alexander seems to have done. Ward Cunningham authored a number of pattern languages, for example, Episodes, published in 1995. Episodes describes a method of software development. In this pattern language, everything is an event. The really remarkable fact about this text, the reason I included it in this talk, is the close resemblance to what Whitehead said about events. In particular, the 4 stages of an event and the notion of becoming are quite visible here. We are particularly interested in the sequence of mental states that lead to important decisions. We call it a sequence an episode. An episode builds towards a climax where the decision is made. Before the decision, we find facts, share opinions, build concentration, and generally prepare for an event that cannot be known in advance. After the climax, the decision is known, but the episode continues. In the tail of an episode, we act on our decision, promulgate it, follow it through to its consequences. We also leave a trace of the episode behind in its products. It is from this trace that we must often pick up the pieces of thought in some future episode. Ward Cunningham, 1995. To what degree do other software development approaches apprehend that everything is an event? I'm not saying nothing can work unless propositions are expressed in terms of events, and there isn't time to give an assessment of each, but if it's true that the only thing any approach or description can inspire is an event, then perhaps the descriptions that are most definite about describing human process as an event will have the most impetus. If we just dwell on SCRUM for a moment, I think it's interesting that SCRUM defines SCRUM events. Each event is associated with a particular kind of fact that is effectively the decision of the event. We also have the idea of events happening within events and also events happening after events. Since it seems so well defined, why is there so much trouble and strife about how it is actually used? So, part of the big problem with the whole Scrum Agile movement is you've got some great practices, but you haven't worked out the underlying theory yet, and until you work out the underlying theory, it won't scale, and it won't have bite, other than in isolated cases. It's Dave Snowden, 2011. So let's see what else there is to know about Whitehead's theory of events. Let's briefly look at the episode which gave us process and reality. I've arranged this slide following Whitehead's 4 stages of an event: datum, process, satisfaction, and decision. First the datum. Whitehead read the Greeks in Greek when he was a boy. We can read in his book Process and Reality that Whitehead found the considerations of the Greeks and the ideas of Plato, Aristotle, Descartes, Kant, Hume, Newton, and so on a mixed bag, although he found many things to like, to which he says he recurred. He felt there was an overall incoherence and individuality, and individually their ideas mistaken in various ways and in consequence rather laboured. Whitehead wrote, "An endeavour has been made to point out the exact points of agreement and disagreement. He appropriates their work, making his own propositions, reworking things whilst giving lectures until he reaches a satisfaction, then his book is printed. All his notes and manuscripts were destroyed when he died on his wishes, so all we've got is the book. That was Whitehead's process. I don't have time here to go into which ideas he took from whom and what he rejected, except to say he takes the notion of a multiplicity of actual entities from Descartes. He rejects the substance quality form in favour of occasions of experience, which he takes from Locke. He says his system of ideas is also a monadology, like that of Leibniz, but the difference is that Whitehead's monads don't change. I mention this shift in the meaning of multiplicity of actual entities because it seems to describe the turn to event sourcing and event storming within the domain modelling community. The satisfaction is the coherent system of ideas called philosophy of organism, which contains the claim that the actual world is built up of actual occasions. The decision comes in the form of the printed book, Process and Reality, which apparently was a little bit botched in the printing process, partly because Whitehead didn't seem to enjoy copy editing very much, and also because one of his publishers thought his manuscript needed explaining a little bit more and so changed a few things. That's why a corrected edition was published in 1979. So now let's look at the scheme of ideas itself. Whitehead called the system of ideas in his book, Process and Reality, the philosophy of organism. Philosophy of organism is the doctrine that the creative advance of the world is the becoming, the perishing, and the objective immortalities of those things which jointly constitute stubborn fact. Whitehead writes, the philosophy of organism is a self-theory of actuality. Each unit of fact is a cell complex, not analysable into components with equivalent completeness of actuality. The cell can be considered genetically and morphologically, which is a distinction Alexander picks up later. I'll try to quickly skate over the main concepts as it relates to domain-driven design. At the top of the list is creativity. Creativity is the universal of universals, the highest generality at the base of actuality without character, like Aristotelian matter is without character. Then we have occasions of experience which perish but do not change. They are what they are, which is exactly like the immutable design of domain events and event sourcing. The so-called actual entities are actual occasions of experience, a statement which is reflected in the database entities of a domain event store. Whitehead wrote, I shall use the term event in the more general sense of a nexus of actual occasions, interrelated in some determinate fashion in one extensive quantum. An actual occasion is the limiting type of an event with only one member. And since he mentions quantum, I think it's worth mentioning that quantum field theory is an important part of modern physics. It is the field that is quantized, and each quantum has a history of states resulting from events, which are the particles, but I digress. Next in his scheme, we have Whitehead's notion of society, which is when elements of a nexus are united by a defining characteristic that is common to all of them, or that they have all inherited from one another, or acquired by a common process. Societies are self-sustaining. The real actual things we encounter in the world are all societies. Whitehead also calls them enduring physical objects. A building is a society or an enduring physical object. For that matter, so am I myself. A non-social nexus is what answers to the notion of chaos. The eternal objects are forms of definiteness, pure potentials realising a particular actual entity contributing to its definiteness. Eternal objects tell no tales of actual occasions. There are no novel eternal objects. Whitehead defines eternal objects as follows. Any entity whose conceptual recognition does not involve a necessary reference to any definite actual entities of the temporal world is called an eternal object. This means that eternal objects include sensory qualities like colours, blueness or greenness, tactile sensations, roughness or softness, conceptual abstractions like shapes, a helix or a dodecahedron, and numbers, 7 or the square root of -2, moral qualities like bravery or cowardice, physical fundamentals like gravitational attraction or electric charge, and much more besides. An eternal object can also be a determinate way in which a feeling can feel, an emotion or an intensity or an adversion or an aversion or a pleasure or a pain. A world is a nexus of actual entities. The actual world is a process, and the process is the becoming of actual entities. A world of one actual entity sinks to the level of a subordinate nexus in actual worlds beyond the actual entity. worlds within worlds. There is a theory of feeling. In this theory, a feeling is a process of appropriation of other actual entities. A feeling is in all respects determinate, with a determinate subject, determinate initial data, determinate negative prehensions, a determinate objective datum, and a determinate subject form, just like code smells. For Whitehead, conscious intellectuality is a higher grade of mental activity. Whitehead suggests mental activity is one of the modes of feeling belonging to all actual entities in some degree, but only amounting to conscious intellectuality in some actual entities. So if a society has personal order, there is a serial ordering of its members. This is very much the same as an event-sourced aggregate in domain-driven design, where the events are positioned in a sequence using integers or timestamps. Whitehead describes a single line of inheritance of its defining characteristic and refers to life history. A corpuscular society is made of strands, each with a personal order. This is like a domain model comprised of event-sourced aggregates. There is a theory of extension, which brings us back to greystones and named persons and so on. There is a theory of living persons, are subjective feelings, are private facts, events that derive from the world. We emerge from the world, as Whitehead said. We essentially arise out of our bodies, which are the stubborn facts of the immediate relevant past. We are also carried on by our immediate past of personal experience. We finish a sentence because we have begun it. So finally, we get to my diagram of Whitehead's event. Let me just get all this up. There. So you can see the four stages. On one side, the datum is the objective content of the experience, facts from the subtle world. On the other side, the decision constitutes the event's actuality as stubborn fact which cannot be evaded. Whitehead wrote, thus the datum is decision received and the decision stage is decision transmitted. In between these two are process and satisfaction. The process solves the question of what the event is to be. It finds a settlement in its datum. This is what Christopher Alexander calls harmony-seeking computation, which reflects Brian Goodwin's work. Satisfaction, Brian Goodwin really liked Alfred North Whitehead too. Satisfaction forms a subjective unity or harmony. Harmony is used in the same way in both Alexander and Whitehead. The final satisfaction is the individual unity of the event. The subjective aim is a proposition. The subject of the event is the event itself. The function of a proposition is to lure feeling. The feelings are what they are in order that their subject may be what it is. The feelings aim at the feeler as their final cause. A feeling is an aspect of its own subject. The becoming of an event is creativity under certain conditions. It is only by means of its feelings that the subject objectively conditions the creativity transcendent beyond itself. Whitehead writes, this conception of an actual entity in the fluent world is little more than an expansion of a sentence in the Timaeus, which is a book by Plato. Plato wrote, but that which is conceived by opinion, with the help of sensation, without reason, is always in the process of becoming and perishing and never really is. There's one more thing I wanted to include here, Whitehead's notion of function. Whitehead wrote, to function is to contribute determination to the actual entities in the nexus of some actual world. As Ward Cunningham wrote in episodes, programming is the act of deciding now what will happen in the future. So there's a parlor game you can play with this where you can use the diagram to model anything by turning the different bits of the text into questions. So obviously the first thing to do is to ask, what does domain-driven design look like as an event? So if I get all these things up here too. Then, I'm just putting it out there. This isn't too serious, but I don't think it's too wrong either. We point the way to the core domain with a domain vision statement. That's just straight out of the book. The domain vision statement functions as subjective aim. The core domain of the software application is perhaps the final reality. We learned from the inside covers of the Blue Book that names from the bounded context and the core domain enter the ubiquitous language. Modelling out loud gives us an opportunity to feel how coherent the ubiquitous language is. This provides the possibilities for a more coherent unity, and so by using the building blocks and through a process of evolving order, we find satisfaction with a subtle design. The concrete result is a model-driven design. Perhaps if that doesn't characterise the situation, it includes some of the main points. That involves software, domain-driven design involves software development. So what does software development look like as an event? I mean, this is also not entirely serious, but we have a similar thing. We have the datum trying to, a process of appropriation, there's requirements development. Then there's something which tries to find a harmony within the code and the backlog itself. You make a code improvement until you have some satisfaction, and then there's a decision which is kind of either committing or publishing, or there's some stubborn fact which you commit to. So this diagram works for both adding and refactoring. Refactoring is an event, and so is adding. The difference is that refactoring makes a coherent unity from something that was troubling within the existing code. What is felt is a code smell. On the other hand, adding makes a coherent unity from the combination of existing code and the fact of an unsupported requirement. Perhaps the trouble is the way developers are involved in the software development process, in each other, how their processes start to combine. How do you model that with events? I don't think we really do at the moment. How do such situations actually become functional so that working software is produced? I don't have any great new methodology to suggest, but perhaps we could be more definite that software development is an event, and perhaps it would help to be more definite about the human development events within software development. I don't really know what that means, but now we know we are looking at events and looking for patterns in events rather than looking at patterns. Perhaps we can find some new things to say about this. And, you know, here's another one. Here's a diagram of human development as an event. Now I'm really getting out of my area. Something about the how-to genre, about stories, something about informed consent, responsibilities. I don't have the answers, so I'll skip on. So what happens if we look at distributed systems as a multiplicity of process events in which domain events may be generated? Can we be more definite about reliability in a distributed system that processes events, processes domain events by being more definitive about what actually happens in that processing? If we want to make a system that is reliable, what can we actually rely on? Is it possible to define the process events in terms of only things that we can rely on? So as far as I was able to work out, the only things that are really 100% reliable is ACID database transactions and counting. And you can make a distributed system on that. So let's firstly pick out the domain events. Here's the domain event as a kind of Whiteheadian event. There's an operation call, perhaps a command is executed, let's say an aggregate method is executed, and some domain events are produced. The stubborn facts are made when the domain events are written into a database. So, domain events. Let's say we process a command. Let's say we've got that happening here. So we process a command, send notifications of the domain events over a bus. So we did what we did before, but now we want to notify some other thing because we're doing messages, and distributed systems are about passing messages. So that's what we do. We pass a message. This is unreliable for the reasons explained before. If the domain events are written first, the notification might not be sent. And if the notification is sent first, then the domain events might not be written. Even if the domain events are written atomically and the view is updated atomically, it remains that the notification isn't atomic with the domain events, and so the consumption of the notification isn't atomic with the updating of the view. So there's lots of ways in which it can go wrong. However, if the notifications and the domain events are written atomically, and the view is updated atomically, However, if the notifications and the domain events are written atomically, and if the view is updated atomically with a tracking record that shows which notification was last processed, and if we use counting to sequence and follow the notifications, and if processing is resumed using tracking information, then propagation and projection of the state of the application will be reliable. For details about doing this with notification logs, please see the relevant section in the book Implementing Domain-Driven Design by Vaughan Vernon. We can take this at least one step further by replacing the view in the bottom right with an event-sourced model. If we make the view event-sourced, then we are basically projecting the state of one application into the state of another application. In this case, we have to put three things in the database atomically: the tracking, the domain events, and the notifications. That more or less defines what a process event is. Using only counting and local atomic database transactions, so long as the infrastructure allows the process to advance at all, the event processing can advance reliably. So here's the process event drawn as an event. The subjective aim is perhaps to keep up to date. The datum is more or less the domain event notification, the current state of the application, and the application policy itself. That's what the process event feels. The process is to apply the application policy whenever there is a new domain event notification. The satisfaction is the new domain events that satisfy the policy. The decision is whether records of the process event are actually written into the database or perhaps not, depending on infrastructure failure. And hence the application state becomes mutated somehow. Here's the process event written as a design pattern. I won't read it all out. It probably needs more work. But it basically says that by using counting to sequence the domain events of an application and atomic database transactions to record each process event, application state will be entirely unaffected by infrastructure failures. And factoring out the process event functionality allows an entire system of applications to be defined independently of infrastructure, not just the domain model. Infrastructure is involved only when the system is run. Runners for single-threaded development and testing, multi-threading, multi-processing, clock stepping, actors, reactive, whatever you want to do, you can bring it together and run it whichever way you want to. And that leaves more time available for domain-driven design. I thought I should mention there is working code for all of this in a project on GitHub. My library for event sourcing in Python. I don't know how many people here use Python. In DDD terms, this is a cohesive mechanism. Eric Evans wrote, partition a conceptually cohesive mechanism into a separate lightweight framework, particularly watch for formalisms, for well-documented categories of algorithms, expose the capabilities of the framework with an intention-revealing interface. Now the other elements of the domain can focus on expressing the problem, what, delegating the intricacies of the solution, how, to the framework. I was going to show you some code, but I thought I'd not bore you to death. To round off, as the dictionary says, we can use events to describe everything that happens in a domain, and now we know what an event actually is, we can see that every domain can be exhaustively described with events. My hope is that as you start to see everything as an event, you feel more real and more alive, and so can operate with more definiteness than before. As Whitehead said, there's no going behind the events to find something more real. In other words, we exclude nothing by tackling complexity in the domain by its events, and I think that's a useful thing to know. That's all I've got. Thanks for listening.